done. It's all comes down to this. The secret of these is really to draw yourself a right triangle. And remember, we talked about how it's most important to make sure you identify where your theta is. So I'm going to mark my theta. And then I'm going to start using what I know. The only thing they've told me is that this is a right triangle and that I have this one trig function right here. They gave me cotangent. So we need to tap into our memory and remember the 6 formulas. And these are what I affectionately call the parts of the triangle formulas. We know sine is opposite over hypotenuse. We know cosecant is the reciprocal function of sine. So we're going to flip these parts over, and the parts of the triangle for cosecant is going to be hypotenuse over opposite. So you can flip the parts just like you can flip the numbers like we did in the last video. So cosine is the reciprocal function with secant, so I'm going to have hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so we're going to go adjacent over opposite for its parts. Now, the adjacent over opposite one right now is the one that's useful for us. So I'm going to take my adjacent over opposite parts and I'm going to put it right up here, right on my paper where I wrote this down. I'm going to write adjacent over opposite right next to my numbers. Now I'm going to use those numbers and label the parts of my triangle. Now remember, we picked our theta. So from the theta, from the angle that I know or that I want, I'm going to go adjacent is right next to it. So I'm going to actually label it with an ADJ for adjacent. And the opposite side, go right through the middle of the triangle, and I'm going to label this with an OPP. Take the time to do this because it's going to be useful when we get to filling in all the other numbers. We know hypotenuse is always across from the 90, so I'm going to put a hypotenuse, HYP, on the hypotenuse side. Now I'm going to take the numbers I know. The adjacent side is 16, so I'm going to put a 16 next to where I wrote adjacent, and opposite is 11, so I'm going to put 11 right on my diagram. So then I'm going to set myself up to solve the problem. Now, I'm assuming that this remember cloud that I have over here on the right side is something that's on notes on maybe a separate sheet of paper. So we're going to set ourselves up on our paper to solve this problem. We know we need all 6 trig functions. So we're going to set ourselves up and write it so it's nice and organized. Sine theta, cosine theta, tangent theta. Notice I'm saying the whole word, not just sin, cos, and tan. And then the reciprocal functions are going to go over here. I'm going to leave space for a couple rows of writing. So the reciprocal of sine is cosecant theta. Reciprocal of cosine is secant theta. And the reciprocal of tangent is cotangent theta. Now, since I have my parts of my triangle formulas already written up here on my yellow cloud, I'm not going to write them again. I am going to fill in what I do know. I know cotangent is 16 over 11, so I'm going to go down to my cotangent theta and put my 16 over 11 in. Now, I might as well use that. I know tangent and cotangent are reciprocals, so I'm going to take the 16 over 11 that I know. I'm going to flip it over. And that gives me my tangent is 11 over 16. So we're a third of the way done. Woohoo! Sine, now I just kind of work my way through the other 4. Sine, I know the parts are opposite over hypotenuse. So I need my opposite, which I have is 11. My hypotenuse, I don't know. So I'm going to put a C up here on my triangle, and I'm going to use our Pythagorean theorem. This is a right triangle, so I can use the Pythagorean theorem. I know 2 sides, I want the third. Remember, in Pythagorean theorem, this C squared has to be the hypotenuse. So since I don't know the hypotenuse, I labeled it C in my diagram. I'm going to leave the C squared in my algebra work right here. And then I'm going to put my other 2 sides in for A and B. Doesn't matter which one goes in for A or B because this addition that we're working on is commutative, which means we can switch the order. So it won't matter, it won't change our answer if we switch the 16 and 11. Now when I do 16 times 16, I get 256. We got to do our order of operations. Exponents have to happen before this addition. 11 times 11 is 121, and that's going to equal C squared. I'm going to add up the 256 and the 121, and I get a 377. That's going to be equal to C squared. Remember, we're always copying all our work down to our bottom line and are keeping it nice and organized. I don't want C squared, so we're going to square root. just to keep it pretty, I'm going to go square root of 377 is equal to c. Now, you guys remember, whenever we square root, it's plus or minus. But since we are working on the length of a side of a triangle, we get to ignore the minus for a good math reason right here. Now that I know my hypotenuse, I'm going to come back up to my triangle and I'm going to write that number, that square root of 377, right on the triangle, because now I can go back to my triangle and fill in these other parts. So I know my hypotenuse is the square root of 377, so I can put that in the bottom of my sign fraction. I think I'm going to go back to my other pen color. Cosine is adjacent over hypotenuse, so I go to my diagram. My adjacent is 16. My hypotenuse, I just figured out, is square root of 377. I've got reciprocal functions over here waiting for answers. The cosecant is the reciprocal of sine, so I'm going to put that square root of 377 on the top of my cosecant fraction. And my 11 that was on the top of the sine now becomes the denominator in the cosecant. Same thing with the cosine, changing it to secant. We're going to flip that fraction over, the reciprocal functions. So I'm going to go square root of 377 over 16. Now we have one more issue. When you go to put these in big ideas to see if you're right, now this problem is not actual problem from your work, but you can follow all these steps. Big ideas wants denominators that are rationalized, which means we don't get to leave the square root of 377 in the bottom of our fraction here. So we're going to rationalize our denominator. We're going to do our favorite thing, multiply by 1, in a form that's useful to us. In this problem, the square root of 377 over the square root of 377 is useful to us because that's going to get rid of the square root in the bottom of the fraction. Same thing on our cosine. I've got a square root of 377, top and bottom, so I'm multiplying by 1. I can multiply by 1 anytime in any form that I ever want to. I'm going to use the magic of this thing and move this over. I thought I gave myself enough space, but I didn't, so I'm going to scooch this over. Oops. And I should probably fix that secant. That looks funny. Put that S back over here. Alright, so now I'm going to switch to, I don't know, maybe blue. So my final answer for sine with a rationalized denominator is going to be 11 times the square root of 377 over 377. And that's what you would put in your big ideas answer box. The cosine then in rationalized form is 16 times the square root of 377 over 377. So there are all 6 trig functions here. Let's pick a pretty color. Let's go with, I don't know, yellow I guess is probably the best. These 6, my sine value, my cosine value, my tangent value, my cosecant value, and my secant value, oops, one more, cotangent value. Those are the 6 values that would go in your 6 answer boxes when you work this on Big Ideas Math. All right, have fun with this. See you later.